Hey guys, welcome back to the NetHTTP series here. So we're going to be covering how to handle JSON, how to decode JSON, how to send it to the client, or whatever HTTP client is sending a request to our server, how to respond with JSON. So let's go ahead and do that, guys. So far we have basic handlers and handler interfaces. So let's just comment this stuff. So this was the handler interface. This right here was a handler function, right? Okay, and this was just our main function. Let's go ahead and add on to our handler functions. So we can make a handler function called getJSON. Since it's a handler function and it's going to be used by our router, we want to use the same exact parameters. It has to have the signature for the function for it to be a valid handler. And what we're gonna do, we made it, so let's just go ahead and add it to our router. Let's do that first. So we can say handle func, and we're gonna say this endpoint's gonna be called JSON, and it's gonna be having the getJSON handler function. Alright, so we can go back here and add the logic now. Now, let's think about how we want to respond based on, okay, so if we're responding with JSON, it depends on what HTTP request we're getting to our endpoint, right? So we can make a GET request, we can make a POST request, a PUT request, a delete request. All these types of requests can be sent to our endpoint here, and we want to respond differently based on those with JSON, of course. So the way we check what type of request is being made is we can go here, and of course, if you probably see it by now, we can use this right here to check the method. Now we can go ahead and use dot notation to look at all the stuff here, and here we can see we have something called r.method. And if we look into this, we see it has a string that gives back either get, post, put, depending on the HTTP request, right? And we can obviously use a conditional here, and we can use some control structure like this to check if it's equal to maybe like get, and we can copy and paste this, and you know the rest, guys. We can do our logic based on this conditionals. Now a much more elegant way to do this is using a switch statement, so let's go ahead and do that. We can add a case here, get. Okay, post. Now here we can finally use, or we can write the logic based on what HTTP requests we are getting from the user. However, we also want to write some headers. So here, how we write some headers, a keyword is write. We use the response writer, so we use w.header, and we set the values. So we can do key value pairs using the set function. You see key and value as the parameters. So the key is going to be content type. And the value is going to be application/JSON. Hopefully you guys are all with me. We're setting the header. Now we want to set the status code, and we can do this again in the header. We can write HTTP status. Okay, that's going to be a 200 HTTP status code. And once we've done that, we can finally write the JSON. Now, JSON in Go is interpreted as an array of bytes, or array wouldn't be the right word, slice of bytes. So this is how Golang interprets JSON. So if we want to write JSON, we do w.write, okay? And we can't just go ahead and say message is equal to JSON, or message is equal to like hello world. Right, we can't do that. This isn't even valid JSON. Valid JSON will look like this, right? Alright, so that's how it will look like. And we see that we're using double quotes within our string, and that's a good indication to use backticks, so we don't get, it helps us avoid any problems with the double quotes. And there we go, that's valid JSON. We want to actually not say hello world, instead we want to say like get is called. Now, if you guys haven't understood why it's giving me an error, it's because JSON is interpreted as an array of bytes or slice of bytes, so we'll have to do some casting here. So if we cast this into a slice of bytes, we are good. Now we can just go ahead and do the same exact thing into the post. Say post is called, and there we go. Let's go ahead and run this. I think I was already running it from before. Okay. Alright, awesome. So now we have our server running. And let's just go ahead and make a new terminal here. And we can curl this endpoint here. Now we could use the browser and use the dev tools to check if it's getting JSON back. This is much more easier. We're going to do HTTP actually. HTTP localhost port 8080. Alright, so now we get a response here, and we can see this, the messages get is called. So by default, if we just do a request here, it's going to be a get request. Status code, the status description, everything's right there. So now let's switch to bash. Hold on. Not what I wanted to do. Okay, so now we want to do a curl request. This time it's going to be a post to the same exact endpoint, and we see the post is called. So there we go, guys. That is how you guys respond with JSON. So if that was easy, that's good. You guys are keeping along. Now, what if we want to accept something from the user? Sometimes in a post request, obviously, the client is sending data to our server, and we're gonna have to validate the data, check if it's correct, maybe there's something wrong, maybe it doesn't match what's in the database, say the passwords don't match. So that's easy. What we'll have to do is say something like, we'll have to make a struct. And this struct has to match the body of the JSON. So we'll just say, we'll use a user, for example, a user struct. Okay, say type user struct, and we'll say name, string, password, string. Okay, we're gonna have to use something called struct tags. Now, struct tags is useful because it allows us to handle metadata. In this case, it's called JSON. This will allow the package of the encoding / JSON package to decode, say, a body of JSON into our struct. So it doesn't make sense right now. I think I lost you guys, but it'll make sense in a bit. So we'll just have to make this like this. Use the syntax here. JSON password. Alright, so now we have to import this package here. Encoding / JSON. And this will allow us to encode whatever we're getting from the client into our struct, and the way it does that is with these struct tags, making sure they match the property. So now I hope the struct tags make a little sense. So we can go into our handler functions, and we can make a new handler function here. We're gonna say func check user. Since it's a handler function, it has to have these parameters here. And now what we have to use is the JSON package, right? So we'll say json.newDecoder.decode. And what does decode give out? What decode gives out is an error. So we're gonna have this set this equal to an error. Now, new decoder is gonna take the body of the request. So let's put r.body in there. And now decode is going to decode the body into the struct. So let's make the struct right now. Now we can say user is equal to user. Now the reason why I don't want to do this is because when we use the walrus operator, this is called the walrus operator, we're declaring. What we want to do is instantiation, and that's doing this. Okay? And that's not setting equal to anything, it's just instantiating. It's not declaring it to anything. And we can put it in here. Perfect. Now we have to do some error checking, of course. Let's do log.fatal, error decoding into struct. Alright, perfect. Now, say this is useful now, guys, because now whatever is in the request, it's now put into the user right here, this user variable. So we can say, for instance, you know, say we had a database password is equal to, like, I don't know, Texas or something. Now we can check if user.password is equal to db password, then we're in the clear, right? Or we can say success logged in or something. All right, so that's very useful, because now we're accepting the body from the, you know, a lot of forms are in websites, so whatever the form is, like the username, the password, we can accept that data, decode it into this struct here, and we can check if the passwords match. Also, we can go ahead and log this or print this out to the client. So we can say this. We want to give it the writer, of course. We're going to say response, and it's going to be this escape sequence, I believe, and we can go ahead and type in user. All right, so I'm going to use Postman. I'm going to use Postman for this, so let's go ahead and Postman. All right, believe this was a different endpoint. Did we even make it yet? Oh, we haven't even made the endpoint yet, so let's go router handle func / user. This is going to be called check user. Okay. Now this was a different endpoint for my website, for Breezy Sites, so we'll just have to change this. Now this body right here, so if you're starting fresh, you're probably going to be seeing this. You want to go to the body, and you want to click raw, and you want to change this to JSON. Once you change that to JSON, you want to make sure that these struct tags have the exact same name as these keys right here. So it should be name, and it should be password. The name could be Fabio, and this could be, I don't know. I really like to play Alistar in League of Legends, so we could make it Alistar. Okay. And let's just go ahead and make this Alistar as well, so we get this here logged in. And let's send this request. We have to run the server one more time though. Okay, and let's go ahead and make this request. It should be a post. All right, awesome. So this is the response. It's Fabio Alistar, correct? And we see it's successfully logged in. So that is how we would handle JSON within our net HTTP project or application. So I hope you guys are happy with that. Of course, we don't want to check these. You know, if you're using net HTTP by itself for a large-scale application, you're doing it wrong. You should use some type of web framework. But overall, this is the basics of net HTTP. It should get you familiar with making APIs and you know, servers. So yeah, thank you for watching, and I'll see you in the load balancer series. Peace out, guys. Thank you.